Hello students, today we will discuss about the dynamic RAM. This is one type of memory. Okay, so this is a very simple memory. It requires very small size as compared with the SRAM. So as it requires one transistor and one capacitor or one cell. You can see here one transistor and one capacitor is required for one cell. So area required for this memory is very small. Okay, hence this cell is smaller in size than SRAM, so more number of cells per chip will be formed, but it requires longer access time. Means for read-write operation it will take more time. So we'll see how the write operation and read operation will be done. For write operation, so for write operation we have to store the data onto these capacitors. That is, we have to store the charge onto these capacitors. Now to do write operations, we have to make this bit line is equal to high or low, whatever the data you want to write that. So we have to make data line this bit line or data line is equal to 0 or 1. Okay, and then word line we have to make it active. When word line is active, the transistor will be on, and whatever the data you want to store, that will be moved onto the capacitance. Means if it is 1, the capacitor will charge. If it is 0, the capacitor will be discharged. And in this way, the data will be stored into the capacitance. So in case of write operation, so write operation is quite different. So into this, precharge bit line to intermediate voltage. So bit line we have to arrange this voltage at intermediate voltage level. Okay, then we have to activate the word line. Okay, now if we activate the word line, the transistor will be on. The voltage onto the bit line, if previously stored data is 1, then the capacitor will discharge. So it will sense that the data return is 1, and if previously stored data is 0, then this capacitance voltage will start decreasing. Okay, capacitance voltage will start increasing, and hence it will sense that the data will be is equal to 0. Okay, so in this way it is going to sense the data, and it will amplify the data, and it will store. Okay, or it will read it. Okay, while doing this, there may be possibility of there may be possibility of vanish of the data, so that the data must be restored first, and then it will be read operation will be done. Okay, so then we'll go towards next slide. That is, so one more problem with the DRAM is that charge stored onto the capacitor decays. As you know that you have seen the diagram of dynamic RAM, that is, when the data is stored, this this transistor will be deactivated. It will be isolated from the bit line. Means there, so charge onto the capacitance will be the continuous, but it is not ideal capacitance. So, and this is not ideal transistor. It is having leakage. This capacitor also having leakage current. So hence the data stored or the charge stored onto the capacitors goes on decreasing, and after some time the data will going to be, the charge is going to be vanishes, and hence we need to recharge the, again we need to charge that capacitance according to whatever the data stored here. So it is nothing but a replacement of the data. Hence there is a need to sense whatever the data stored periodically, and we have to rewrite the periodically, and this process is called as a refreshment of the data. Okay, so typically every cell is refreshed for every 64 millisecond that will be given by the manufacturer. Okay, so this 64 millisecond is given by the manufacturer. Every cell is refreshed after every 64 millisecond. Okay, so we have to refresh each memory cell, or we have to refresh each memory location. These memory cells are arranged in array. So this array is nothing but one bank, and this bank are recharged or refreshed periodically by row, or these are refreshed whole row at a time of one bank, and then next bank. Likewise, these cells are refreshed. So while refreshing, we can't access the data. Means while refreshing, we can't read or write. Okay. So if you do read write operation, then we have to leave the refresh cycle, or interleave refresh cycle among the accesses. Okay. So we can do refresh at a burst after every 64 millisecond, and other time we will do the other accesses. That is, we can do a rewrite operation in other time. Okay, but after every 64 millisecond we have to do a refresh cycle. Okay, we have to refresh the every cell. Okay, so we know that the dynamic RAM is required very small in size. So number of cells per chip is going on increasing. So density of the chip is more, but it requires a refreshment cycle. Okay, and hence the access time is more. That is the drawback, but you can manage with the cost. Okay, so main memory of the computer is formed by the dynamic RAM. So it has very fast applications as it has very low cost. Okay, so then we'll go towards another memory, that is ROM. That in case of read only memory, when at the starting, when there are the memories are used, at that time one memory it is used for read write operation, and other memory it is used for only read operation. Sometimes the applications, or many applications, we require the unchanged data, that is, we require the constant data, and it is not required to periodically update the data. Okay, so for that purpose we require the read only memory. Okay, in ROM contains data will be constant, and this data will be written by the manufacturer. So manufacturer know that this data will be stable for their lifetime. Okay, they sure that the data is not going to be changed over a lifetime. Okay, but in some cases we require the data to be changed periodically. So that time we require the program ROM. So in this way you will get the ROM again two types, that is, one is a one-time programmable and another is a programmable ROM. Okay, so in case of one-time programmable, OTP, one-time programmable, so that is masked programmable. This data or this memory is manufactured by the, or this memory is written by the manufacturer itself, and this memory will be written by using fusible links. This memory is formed by using fusible links, and this memory is written by using fuse blowing. Okay, once that fuse is blown, and we can't change the data. Okay, and hence this type of programming will be permanent. Okay, so this is one time programming, and in case of another, that is programmable ROM. In some applications we require whatever the data stored, we have to change it periodically. Okay, we have to update it periodically, and hence we require programmable ROM. Okay, so there are again different types of programmable ROMs. Means we can program it, we can write it, but whenever you want to restore it, we have to erase first it. Okay, depending upon how we are going to erase, there are different types. That is, by using, we can do erasing by first ultraviolet rays erasing. Okay, in this case, ultraviolet rays are bombarded for 30 milliseconds through a window that is on memory. That from that window, ultraviolet rays are bombarded for 30 milliseconds, so that whatever the data will be written onto the memory, that will be the removed out. Okay, and again you can program it. Okay, so this is one type of programming. And electrically erasable programmable memory, that is EEPROM. In that case, by using transistor turn on and turn off, we can make it, we can erase it. Okay, we can erase line by line, we can erase word by word in case of electrically erasable programming. Another type of memory, it is flash RAM. It is again by using NAND transistors and NOR transistors, or it is by using NAND and NOR technology. So they are erased by block, okay, and hence this type of memory, it is called as a flash RAM. Okay, so next is the combinational ROM. So combinational ROM, it is a combinational circuit. Okay, the ROM maps input address to the data output. ROM maps input address to the data output. Okay, here this ROM content in tabular form in row wise, and each address having one entry. So this entry is such as that a truth table. This entry is such as a table, and that table is nothing but a truth table. Okay, and in this case, combinational function is used instead of the gate level logic. Okay, combinational function will be used instead of the gate level logic. Okay, so then in the combinational circuit, this combinational circuit is suitable for the finite state machines. So in the finite state machine, this will be used for the next state logic as well as the output logic. One of the example where we can use the combinational ROM, you can see that is we have discussed 7 segment decoder. Okay, so that is where we have used input data is BCD and one more blank input is there, and we are going to give it the decoder output to the 7 segment display. Okay, so we require the fixed code words for it. If it is a 000, that is for 0, so you require the 4-bit data, and one more is the blank input. So that is 5 inputs, and will require 7 number of output for 7 segment, because that is you will get the 7-bit code word for it. And so you know that this program that we have written it, and so as there are 5 number of inputs, we require to raise to 5 number of memory segments. Now you can see how the combinational logic is designed for it in detail in the book. Okay, this is about the combinational ROM. Then we go towards the flash RAM. Okay, so flash RAM, it is again non-volatile memory. Okay, so this is a new technology, and in every new technology this RAM is used. Okay, so this is again electrically erasable memory, but erasing will be done by block or page by page, and programmed by cell by cell. The flash memory have limited number of erasing operation, that is hundreds of thousands before it wear out. Hundreds of thousand number of operations we can do it, we can erase and we can again rewrite. Okay, so read operation will be relatively faster and write operation will be relatively slower for this flash memory. There are again two types of flash RAM. Okay, that there is a NOR flash and NAND flash. Okay, so NOR flash, you can see NOR flash can write and read individual locations, and you can see here, but NAND flash we can only write and read block by block. Okay, block at a time. Okay. So NAND flash required less area as compared to the NOR flash, and hence NAND flash are the more denser as compared to the NOR flash. Okay, so this type of memory is used in case of embedded programming. Okay, so it is used for the programming storage and for random access of the data. This type of memory, it is used where we require to store the data will be in bulk, but access time is more, and hence this type of memory, it is used in case of cameras or memory sticks of the personal computers. Okay, so this is about your flash RAM. Okay, so then we'll in the next video we'll discuss about the memory errors. Today we'll stop here. Okay, thank you.